Good morning. We will start session 5 on triangles. So till now we have seen the congruency criteria, that is how we see SAS, triple S. Of course, yes, in one or two sums where we have got it, or it is ASA or it is AAS. So we have seen these congruency criteria till now. This exercise will be dealing with RHS congruency criteria. That means one right angle hypotenuse and a side. So let us see how to use this. The first one, ABC and triangle DBC are two isosceles triangles on the same base BC. So draw the figure accordingly what it is being given. So these two are the isosceles triangle, that is ABC. I'll mark AB is equal to AC and BDC is also an isosceles triangle. So these two sides are equal. So according to the question, this angle is equal to the whole angle. Small angle is equal to the small angle. Why? Angles opposite to equal sides are equal. Let's keep it as it is. That's all is been given. So given triangle ABC and triangle BDC are isosceles triangle. Hence it is an isosceles triangle. AB is equal to AC and BD is equal to CD. If you want, you can write the angles also here equal. We will write it. So with respect to AB, what angle is equal? Angle ACB is equal to, with respect to AC, angle ABC. And which angles are equal? BD. If it is BD, angle DCB is equal to angle DBC. These two angles which are equal. Rest nothing else is given. What we have to prove? So there are so many things to be proved here. First, second, third, fourth part I will not write because it will not fit in this. Then I have to again write proof and all. So first, second, third, fourth, we have to prove triangle ABD. Okay, we have to join this. Anything else is given to intersect B. Angle ABD, this triangle is equal and congruent to this. That is point number 1. Angle ABP, the whole triangle is equal to this whole triangle, point number 2. AB bisects angle A as well as angle D, that is proved by congruency only. CBC when we get it. The last part, AB is the perpendicular bisector of BC. That means we need to prove AP is perpendicular bisector. It bisects 90 degree and BP is equal to PC. BP is equal to PC can be proved by CBCT. But whenever they ask us to prove that something is perpendicular, that is 90 degree, that cannot be proved directly with congruency, but using congruency we can prove that. Let's see how. Let us start stepwise. So proof in triangle ABD and triangle ACD. Okay. So these two triangles, let us write down what things are equal. First of all, AB is equal to AC and BD is equal to CD. These two are given because it is an isosceles triangle. Then what we have? Can I tell AD is equal to AD? Reason? Common side. Therefore, triangle ABD is equal and congruent to triangle ACD by triple S congruence rule. Now from triple S congruence rule, let me write down the CBCT angles. So what are the CBCT angles there? Can I say angle BAD is equal to angle CAD? Reason? CP, CT. Children, this angle is equal to this. That means, can I tell that AD bisects, AB is being given, right? Okay, last we will write that. AB bisects angle A, can I say? Right? So AP bisects angle A. So this part is already proved. Therefore, AD, which is nothing but AP. See here, AD, which is nothing but AP. Because AD, if I extend, I get AP only. AD by AP bisects angle A. Second part also be proved. This also be proved. One more what they have asked. AP bisects A as well as D. That we should find it later. So now, next which part of angle they have taken here is ABP. ABP and triangle ACP. This part of triangle they have asked us to prove it. So let's check what we will get here. Now here these two angles are equal, that is different, but we want these two to be equal. Let's again take in triangle ABP and triangle ACP. Again AB is equal to AC. AB is equal to AC. This side is equal to this side. Then what else angles are equal here that we have to check. See here the whole triangle, half of the triangle when I talk about and half of this when I talk about. Two sides are equal, already done. Let me draw the figure once again, children. Why? Because there are so many things written in this, it will be a confusion. I draw only this much. A, B, C and P. ABP, that is what they have asked at ACP, right? So let me mark. AB is equal to AC, written. Then can I tell angle ABP is equal to angle ACP? That's because AB is equal to AC. You can write the reason. Angles opposite to equal sides are equal or given. What is the third angle which is equal? Angle BAP. See, BAD or BAP, it is the same thing only. You have just extended the line. Angle BAP is equal to angle CAP. Reason proved above. How many angles and how many sides? Two angles and one side. But actually here if you go to see, AP is also equal to AP, common side. But using that common side, can I prove SAS? No, because included angle will not come. So you can exclude this. If you want, you can even exclude AB is equal to AC and take only AP is equal to AP and prove. That's okay. Choose three criteria such that it should satisfy SAS. If it is not satisfying, leave. Choose such that it should satisfy ASA or AAS. Now here it is only left with this. That means let us choose angle side. Triangle ABP is equal and congruent to triangle ACP by AAS congruence rule. From this AAS congruence rule, two things I can tell equal. That is, I can tell here BP is equal to CP and I can tell APB is equal to angle APC. Reason? CPCT. Right? That means now what all we have proved? We proved first one, we proved second one. Third one we did not prove it completely because I only told AP bisects angle A. It is not still bisecting angle D also. Angle D is this children. Okay? To tell that this angle is equal to this angle, what should I do now? I should prove again congruency. They have not asked, but since we have to prove it, we should prove congruency for these two triangles also. I hope you have written down this much. Now what I will do is I will again erase this. So after erasing, I will choose that those two are okay. We'll do one thing. Shall I rub this figure? Anyways, you all know to redraw it once again there, or we will do it here. A very little portion part is left. Okay, so this was first part. If you want, you can write. This was second part. If you want, you can write. Now to prove third part, first we'll take with that. In triangle BDP and triangle CDP, BD is equal to CD. Okay. BP is equal to CP. BD is equal to CD given. BP is equal to CP proved above. Last, DP is equal to DP. Common side. Which congruence rule? Triple S. Triangle BDP is equal and congruent to triangle CDP by triple S. Now from this, can I tell angle BDP is equal to triangle CDP CPCT. Therefore, can I tell now AP? See, this is also bisector where AP is cutting. This is also bisector where AP is only cutting. So therefore, finally can I give? Therefore, AP bisects angle A as well angle D. I think this is very clear. Now, to prove even here CPCT we could have told this because we wanted this. Until we prove this triangle is congruent, we cannot use this triangle for congruency. It is how you know all are interrelated and correlated. See, we had to prove this so that we got angles here, right? Then we had to choose the whole triangle because we had angles here. That is how it is given. In sequence, the congruency is given. You have to go in the sequence only. So with this, we proved the third part. Now the last part which is remaining, what I have told, AP is the perpendicular bisector. It's already a bisector. Why? The line AP is bisecting BC into two equal parts. It's already a bisector, but not a perpendicular bisector. So how do we do that? So I'll do it in this part. Let me see if I can fit. So I'll again start from this angle now. Can I tell this angle and this angle is a linear pair? Angle DPP we have chosen here, where the two angles were equal children, where it went. APB we have written. Okay, APB. So DPB. Angle DPB or APB only you write. What you have taken that angle only you write in the whole thing. Angle APB plus angle APC is equal to 180. This is fourth part. Linear pair. LP I have written. I don't have a space there. You need not write LP. It should be written linear pair only. But are these two triangles are equal? Yes. I will write 2 times of APB is equal to 180. Reason? Angle APB is equal to angle APC. Therefore, angle APB is equal to 180 upon 2. Angle APB is equal to 90. Therefore, angle APB is equal to angle APC is equal to 90 degree. This implies AP, 90 degree. AP is the perpendicular bisector of BC. Right? Those AP is the perpendicular bisector of BC. Remember, whenever they ask you to prove anything as a perpendicular bisector or it is 90 degree, it is usually proved by linear pair only. To that linear pair, we should have already proved that those two angles are equal. Only then you can use linear pair because you can say twice of. First we proved the triangle's congruency, then we proved the whole half of triangle congruency, then we choose the again part triangle congruency, and wherever possible we wrote all the CBCT sides and angles. With that we took a linear pair and proved it. We'll quickly go with the next one. AD is an altitude. It's a very small exercise. I want you to practice these writers, what we say are the criteria of this chapter, worked examples also. As well, you know, Sunday we have a test on lines and angles. I want you to also practice worked examples on lines and angles also, as well as the assignment questions what I have given to you all. Second one. AD is an altitude of an isosceles triangle. Figure is not given. Draw. So ABC is an isosceles triangle with respect to that. AD is an altitude. What do you mean by altitude? It only, it's a 90 degree, not bisector. It is only 90 degree. If AD was a perpendicular bisector, along with 90 I can also say BD is equal to CD. Perpendicular bisector. AD is an altitude of an isosceles triangle ABC in which AB is equal to AC. So, understood that this angle is also equal to this angle, right? Show that AD bisects BC. We have to show AD is bisecting BC. That is, these two sides are equal. AD bisects angle A also. So, we will go with the given, what they have given. In isosceles triangle ABC, AB is equal to AC, therefore angle C is equal to angle B. For AB it's angle C. Reason you can write angles opposite to equal sides are equal. Then AD perpendicular to BC, right? That's all you can write. That means angle ADC is equal to angle ADB is equal to 90 degree. To prove what they have asked, AD bisects BC, that is BD is equal to CD. What is second part? AD bisects angle A. What do you mean by this? Angle BAD is equal to angle CAD. Angular bisector it is. AD bisects angle A. We'll start with the proof now. In triangle ABD and triangle ACD. First of all, I will write now. Okay, I will choose 90 degree. I'll tell you why. So, angle ADB is equal to angle ADC is equal to 90. Reason AD perpendicular to BC. Then, so we have so many things here, children. Okay, I can even tell that angle B is equal to angle C, right? And I will tell that AB is equal to AC. Assume that. That means I have two angles and a side. Then I will prove this by AAS, right? Is it correct? Yes, of course it is correct, but the condition is whenever you have the pre-existing given condition where we have one right angle, where we have a hypotenuse and any other side, why should you go for AAS? It is not wrong, but it is not correct doing. See, now AAS we choose, SAS we choose, ASA we choose, triple S or triple S will not come only. We choose because we do not have a 90 degree and a hypotenuse. Now here we have a right angle, we have a hypotenuse. How do we know that that's a hypotenuse? An angle opposite to 90 degree and a side opposite to 90 degree is always a hypotenuse. In a right angle triangle, when you say which is hypotenuse, this is hypotenuse because this is 90 degree. So that's a side opposite to 90 degree. So when we have these three existing conditions, how can you choose AAS? So what will happen if you choose AAS? It is not not wrong actually, but you are not advised to choose it. Your teacher can give you wrong. I can say yes, your teacher it might be right. I also will give you wrong because there is a pre-existing condition for RHS. When RHS exists, you can't choose anything else, right? So it is better whenever you come across a right angle, search if you have a hypotenuse. Then go ahead with hypotenuse and one more side. That's also important. Do we have everything? Yes. Now see, A is an angle around say 90 degree. These two angles are equal. This angle is equal to 2 angle. This side. Leave it. I have a common side also. SAS will not come, but AAS can come here, right? Or same thing, AAS this also will come, AAS this also will come. But still, when I have a 90 degree and a hypotenuse, I will go for RHS only. I even suggest you all to go for RHS only. So this is over. How do I write this? Hypotenuse AB is equal to hypotenuse AC given. AB is equal to AC given. Now which side do you want? Common side? Because right angle, hypotenuse and a side. AD is equal to AD. Common side. And whenever you are addressing or whenever you are writing about the hypotenuse, you have to write it like this only. Okay, shortcut I have used HYP. Write the full form if you want. Hypotenuse. It has to be written. You just cannot say AB is equal to AC because that also will look like a side. So write what type of side it is. It's a hypotenuse. So one right angle, hypotenuse and a side. Triangle ABD is equal and congruent to ACD. Now how will you come to know whether this is RHS will come or no? What if you go wrong? Whenever in a given triangle, if you come across a 90 degree angle, check whether the opposite side or any side is a hypotenuse. If it is there, then definitely go for it. Okay. Now with this, let's write CPCD. BD is equal to CD. CPCD. This implies AD bisects BC. Next, angle BAD is equal to angle CAD. CPCD. Reason, AD bisects angle A. So two reasons they had asked, two proving part they had asked, and there we have proved it. Let's quickly go to the next sum. Though the exercise is small, the sums the writers are quite lengthy here. Yes, the next sum we have something called as a median. First of all, you all should know what is a median. Let me first explain that. A median to a triangle divides the triangle into two equal parts. That means, if I tell you A, B, C and AD is the median to the triangle ABC, so BD is equal to CD. Not only that, a median divides the triangle into two parts. Then also we can tell that areas of this, you study about the median property later again here. So now let's only understand a median divides the triangle into two equal parts. That means if I tell you the AD is the median, that means BD is equal to CD. B acts as a midpoint of a triangle. So that property you should know to solve the figure here. Two sides AB and BC and median AM of one triangle. So this is one triangle A, B, C and this is M, and another triangle which is P, Q, R and this is N. So according to them, what they have given, two sides AB, BC and median AM of a triangle is equal to the, so AB is equal to this, then whole BC children. So I will just write like this here. BC is equal to QR and the median of the triangles are equal. It is given like this. Two sides AB, BC and the median AM of one triangle ABC are respectively equal to the sides PQ, QR and median PN of triangle PQR is equal. Show that. Let's write in the given. In triangle ABC and PQR, AM and PN are the medians respectively. So what they have given? AB is equal to PQ, BC is equal to QR, AM is equal to PN. Okay, this was just given here. What we have to prove? And since it is a median, just write here median divides the triangle in two equal parts, that is BM is equal to CM and QN is equal to R. Is this very clear? Okay. To prove, triangle ABM is equal and congruent to triangle PQN and triangle ABC is equal and congruent to triangle PQR. Triangle ABM and PQR, let's start with it. Proof. In triangle ABM and triangle PQN. So where is ABM, ABN and PQN? So write down what things are equal here. First of all, we know that AB is equal to PQ, AM is equal to PN. Okay, all even the base given. Okay. Next, I know that BC is equal, but BC will not come in this, but still I will write. BC is equal to QR. This is also given. Right? How can I write BC? Can I write BC as 2 times of BM is equal to 2 times of QN? Reason? BM is equal to CM and QN is equal to RM. Right? I have chosen this part. So if I can cancel 2 and 2, what will remain? BM is equal to QN will remain. So we are going to use first, second and this side. This is just for writing what was to understand. So by which congruency rule? Triangle ABM is equal and congruent to triangle PQN by triple S congruency rule. So from triple S congruency rule, can I tell this angle is equal to this angle? Yes. I will say angle B is equal to angle Q. CPC. Next. So first part is done. First part of proof is done. ABM is equal to this. Now choose the half triangle. Now choose the whole triangle. ABC and PQR. Second part. In triangle ABC and triangle PQR. AB is equal to PQ. Okay. Angle B is equal to angle Q. Proved above. Then BC is equal to QR. given. Which congruence rule? SAS. Triangle ABC is equal and congruent to triangle PQR by SAS congruence rule. I hope it's very clear. It's a very simple sum where only this thing we need to know what we have to do, and that's only because see they have not told anywhere that BM is equal to CM, but they have mentioned AM is the median and PM is the median. Without that we can't do anything because median property tells us that. Quickly we finish with the last one. They are very simple. So the figure in this exercise, if you have seen, the figures are given. We need to read the question, understand, and then draw on that basis. BF and CF are the two equal altitudes. What do you mean by altitudes? 90 degree. So be very careful. When 90 degree comes, we need to look whether any hypotenuse is equal. Along with hypotenuse, there should be one more side also. Only then you can go for RHS. Sometimes, very rarely they give in the question back, prove this by RHS congruence rule. Very rarely it is asked like that. If it is not asked, it's up to you, but what I suggest is, whenever you have a 90 degree and hypotenuse, go for RHS. Yeah, see here, BF and CF are the two equal altitudes of triangle ABC. Using RHS congruence rule, prove that the triangles are isosceles. They have stated. That means we have to go for it. We have to prove that it's an isosceles triangle. So this is a triangle ABC. BF and CF. This is BF and this is CF are the two equal altitudes given. In triangle ABC, BF and CF are equal altitudes. That is, BF is equal to CF. You can also write that PF perpendicular to AB. BE and CF, right children? Yeah. BE perpendicular to AC. PE and CF are the two equal altitudes. BE is equal to CF, BE perpendicular to AC and CF perpendicular to AB. Okay. To prove ABC is an isosceles triangle, that is AB is equal to AC. Why not I mean B is equal to I will see. Usually when we say isosceles, we say about sides only. So now, if you have to prove the sides are equal, you have to prove that by CPCT. That means we want two triangles for congruency. How to choose the triangle? Choose triangles in such a way that the triangles have the sides AB and AC respectively. Now again see here, you can't be choosing lower triangles. Why? You don't have AB and BC there. That means if you want not BC, AB and AC there. If you want AB and AC, you have to choose the upper part of triangles. Let us draw the upper part of triangle. This is A, this is E, and this is B. A, E, B. Then it is this triangle what I have written. This is again A, this is F, and this is C. Right? So, if I choose here, children, now see what will happen. Can we say, okay, let us choose this. Okay, I have a 90 degree. Then what else is equal? They have also told that BE is equal to CF and it is a common angle, right? So this is done by which one? 90 degrees there. Do we have hypotenuse? No. But this is done by which one? AAS. We will prove it. But what is the question asked for? It is asked for RHS. Then this is not supporting RHS to us. What we have to do? Then this is the wrong triangle chosen by us. It cannot be. Then what should we do? Now we should choose a lower part. But if we choose the lower part, we will not get AB is equal to AC. But what we will get? We will get and angle B is equal to angle C. Right? Let's see. If I choose the lower part of triangle, I'll drop this anyway. I wanted to show you this why we cannot do this. Initially what happens? We start with this. But that should not be the one. This can be done by AAS. But here, if in case it was not asked, if you have chosen this, definitely this would be right. Let me choose the lower part now. So this is E, this is B, C, and this is 90. So if this is 90, this is hypotenuse. BE is equal to that part. Let me draw this side now. Where it comes, this is F, this is 90, so this is hypotenuse. So this is C and this is B, so this is equal. 90 degree hypotenuse on the side. So can I tell angle B is equal to angle C? Yes, angle B is equal to angle C. That means sides opposite to equal, angles are equal. That way we can choose and do. So choose this triangle, not this. In triangle BEC and triangle BFC, angle E is equal to angle F, that is equal to 90 degree. Okay. Hypotenuse BC is equal to hypotenuse BC. Common side. Since it is common, that is why it is equal. DE is equal to CF given. Therefore, triangle BEC is equal and congruent to triangle BFC by RHS congruence rule. You can take it as a homework, children. Saying what? Do not write this using RHS congruence rule. Prove that it is isosceles triangle without RHS. You can also do with this method. Okay. So now since they are equal, so here in triangle angle C, that is C, is equal to angle B. I can tell. Angles opposite to equal sides are equal. So if it is 90 degree, now this is the side. So here this has to be angle B. Now here it is 90 degree. So this is the side. It has to be angle B. Angle C is equal to angle B. This implies angle C is actually what? Whole angle C it is. So whole angle C is nothing but AB. So whole angle B is what? Nothing but side AC. Therefore, ABC is an isosceles triangle. Okay. And the last one. Last one is very simple. It's almost a direct question there. ABC is an isosceles triangle with AB is equal to AC. Draw AB perpendicular to BC and show that angle B is equal to angle C. We need to prove that those two angles are equal. Where they have given sides are equal. It's almost equal to the converse of the theorem what we had done. It's the similar part. ABC is an isosceles triangle. Fifth one. With AB is equal to AC and AB is perpendicular, not bisector, children, it's only perpendicular. Show that angle B is equal to angle C. RHS 90 degree, hypotenuse and a common side. Which postulate? I think you can take this for a homework. In triangle first given, in triangle ABC, in isosceles triangle ABC, AB is equal to AC given. AB is perpendicular to BC. To prove angle B is equal to angle C, choose these two triangles for congruency Angle APB is equal to angle APC is equal to 90 degree. Reason, AP perpendicular to BC. Hypotenuse AB is equal to hypotenuse AC. Given. Then one more side we want. AP is equal to AP, common side. Therefore, triangle ABP is equal and congruent to triangle ACP by RHS congruence rule. From this, angle B is equal to angle C, CPCB. And if you can take this for a homework, a very simple one. With this, we complete this exercise. We are left with the last exercise, that is something about inequalities of triangle, which we will be dealing it in the next session.